So it refreshes our memories on definitions of sine and cosine by, again, looking at the circle with radius 1. And on that unit circle, we have points with pair coordinates x and y. So that's how we defined cosine and sine. So we go with angle. Now they like to call it as theta. And the coordinates such as a x coordinate is a cosine of this angle theta, and the y coordinate is sine. So cosine and sine, those are x and y. And from there, everything starts, and one really needs to realize that cosine and sine are just coordinates of point on a unit circle. And it doesn't really matter what point you select. Like on this picture, they have angle, which is more than 90, but it's still x and y coordinates of point on that unit circle. I, for convenience, like to put it in the first quadrant, but it doesn't really matter. So from here, you can also conclude right away that values of sine and cosine are in between negative and positive 1. For cosine, the boundaries are minus and plus 1, because cosine can only be here in between. And analogously for sine, because that's y coordinate of points, so y coordinates also restricted to negative and positive 1. So this is right out of definition. Other functions for the, I guess, trigonometric story, such as a tangent, cotangent, and so forth, are also present here. And then there are lots of little observations they make related to those. First two are that if you start to rotate by full rotation, which is 360 degrees all the way around, you return back to the same point. So your sine and cosine will stay the same. And that's what they're trying to show here, that sine stays same as well as cosine stays the same if you have this full rotation for those. And then analogously, they coming up with other 6 functions starting from that position. So other 6 are ones such as a tangent, cotangent, so there are others. I guess I'd like to concentrate on sine and cosine, and then we a little by little move to more trig functions. I know we already saw these others, but I guess if you want to get comfortable with trigonometry, if you know everything about sine and cosine, that's pretty much all we need, because the others are just reciprocals. But of course, we're going to also discuss the other functions in very detail. So there are identities that we already saw here. They're in these gold boxes that we hopefully familiar with. So definitions of cosecant and secant, using the fact they're reciprocals of sine as well as cosine. And also, once you know tangent, the reciprocal of tangent will be a cotangent. And of course, vice versa. So sine is a reciprocal of cosecant, cosine a reciprocal of secant, and tangent is reciprocal of cotangent. Well, it could be used when you do various exercises, when you simplify things, but we need to, of course, be familiar with the fact that tangent is sine over cosine. And of course, its friend cotangent, it's reciprocal, so it's a cosine over sine. So it looks like they're going over same things we already discussed in the previous section. And again, that's good because it gives us a chance to reiterate and I guess just better remember what is happening. So technically, they put all of the identities here in a box on the bottom. So in addition to these definitions, we also have some of the Pythagorean theorem statements that we discussed briefly last time. And of course, we're going to be returning back to these discussions again and again because they're very popular. So we saw the sine squared plus cosine squared equal to 1. We also saw that 1 plus tangent squared is equal to 1. And the last one that I also introduced and asked if you want to check it out yourself was 1 plus cotangent. Now, notice it doesn't really matter. You put cotangent plus 1 or 1 plus cotangent. Addition commutes, so result doesn't really matter. It's still the same. So I guess the goal be to do some exercises, but I think there is one more interesting fact here about functions being even or odd, symmetric through x-axis or y-axis. I think I saw these identities here as well. See, in this section, they have lots of little facts, and they're here. So turns out that function cosine is even. In other words, if you place a negative inside, the minus sign will be absorbed. So cosine of theta is same as cosine of negative theta. Well,
I'm sorry, is this 6.2?
it's 3.
Okay, thank you.
So we already discussed 6.2 for last week. I think we spent the whole week talking. First week we talked about 6.1, then we talked about 6.2, and now 6.3, and then later we'll go to 6.4. So we're moving a little by little. So anyways, negative angle means that we rotate clockwise, right? And if you have positive, then it's the opposite direction, counterclockwise. So if you go theta here or negative theta, the opposite direction, it turns out that x coordinate will be the same. Maybe I should put this a little bit larger because it's hard to see what I wrote, right? Get bigger so you better see it. These pictures definitely should be made using plenty of room because otherwise it's definitely difficult to see what's happening. So the key point is we are looking at x coordinate, because that's a cosine. And x coordinates will be the same for those angles, for negative theta as well as for positive theta. And that's why we say it's even, because it's symmetric through x-axis. With a sine, it's different, because when you look at the sine, and that'd be your y-coordinate, right? For theta is going to be here. But for negative theta is negative, right? It's down below. Because sine, again, is y-coordinate. So what we need is to notice the signs are opposite. So if you want to make them be the same, sine of negative theta and a sine of theta, then the minus needs to be placed in front, because that way you're going to make them both positive. So that's another observation that comes right out of the definition of those functions. And the other functions are work in analogous way as well. Again, I don't want to get very deeply into it, but little by little we will be, of course, going over this. So I'm gonna do some exercises. I think it's time. So skill building problems as usual. Let me try some exercises. Let's say start with sine of 405. I think that'd be good start. Just clean this mess up. So we have use fact that trig functions are periodic. And what they want, find exact value. So they just want to find value of sine 405. I guess since it ends with 5, then 45 degrees angle probably is going to be utilized, right? So notice that instead of 405, I can pull out 360 and have it added with 45, right? 360 plus 45. So full rotation will make no difference. I just need to take a look at the 45 degrees angle, because if I add 360 or twice 360 or whatever number of 360s, the result is still the same. In other words, sine of 45 degrees will be exactly the same as one I need, sine of 405 degrees. And if you remember how we found this, I want to get this textbook opened again. So I'm going to go to search and type Sullivan pre-calculus. It's already here. And go to the first choice, because what I care about is the last page for this textbook, because there we have all of these little formulas. Remember the unit circle pictures? So just go to the very, very end. And looks like what I need is a little bit higher. Here it is, right? So on that nice circular diagram, I can get various exact values. Exact means they're not decimals, they're in terms of square roots. Square root 3, square root 2, pretty much that's all it is. And so my question was about 45 degrees, right, which is here. And for that 45 degrees, I have both and sine and cosine that are equal, and they're both square root 2 over 2. And that's just what I needed. So I got the answer, square root 2 over 2. That's so-called exact value because it has square root. And yes, that's all they want. So more of these. Let us try exercise from another group. Let's say, how about number 35? Now it's not from this circle. Now it's a little bit different numbers, right? But that's okay. So we can actually utilize these to, they say, find all trig functions. So they say that sine is negative 3/5, and cosine is positive 4/5. Okay, so I just want to recall definitions of tangent, cotangent, and so forth. So tangent theta is a sine over cosine, right? And then others all are reciprocals, which means that if you want to take cotangent, this is going to be reciprocal of tangent. Of course, angle theta is here. And so forth. So cosecant is reciprocal of sine, and secant is reciprocal of cosine. Doesn't really matter in which order you get those, as long as you give these 6 nice answers. And let us do this. So it looks like for the first one, I divide -3/5 by 4/5. And the quickest way to divide is to notice that denominators definitely could be canceled by multiplying by 5 and then dividing by 5, right? So this common denominator will disappear right away, and you get the answer, -3/4. So I hope you like this method. Again, if you like to do this reciprocals, flip second fraction, you can do that, but again, it's up to you. So if you want to divide 1 by tangent, which is something we just found here, -3/4, I better write it like that because all I need is just to flip second fraction and get it as -4/3. And times 1 means nothing, so this is your result. Analogously with a sine and cosine, so I have to flip this, so I have to divide 1 by that -3/5. So I will say I try to avoid these complex fractions, so I could just flip my fraction 3/5 and get 5/3. And analogously with cosine, so you could just cosine of theta. I think I wrote something not what I supposed to. So cosine of theta is 4/5. Should be careful. So I need to flip that 4/5, and that'd be 5/4, right? But just to be precise, I write 1 divided by 4/5, and that's how we get 5/4. So you have sine and cosine, you have everything. You don't have to make a picture. If you want, you can, but it is up to you. And in the next group of exercises, they also expect you to actually make a picture, because instead of giving you both values for your sine and cosine, they just give you one. Like, for example, exercise 46, they give you only sine, don't give you cosine. So they expect you to find the cosine. And the way to find the cosine is use Pythagorean theorem, because once you have found cosine, then you just repeat the story of previous exercises exact same way. So this exercise has little extra. They give us sine of theta -5/13. So we're gonna utilize the fact that sine squared plus cosine squared is equal to 1, right? Doesn't really matter for what angle. So put angle theta. And from here, you can pull out your cosine squared. So it'd be 1 minus sine, but square root extracted. And notice when you extract the square root, you could be either with positive sign or with negative sign. And that's why they actually telling you which quadrant you're in order to help you decide on the sign of that cosine function. So the angle is someplace here. That's called quadrant number 3, isn't it? We go counterclockwise. That's first quadrant, that's second, and this is the third, and there's fours that sometimes you will put like that. Whatever. So looks like we are here. The angle is here. And please notice that for that angle theta, both and x and y coordinates are negative. You see that? So I have to have a minus in here. And now I'm gonna need to see what will be a square of sine, right? Which is square numerator 25 and square denominator 13 times 13 is 169, turns out. Negative disappears. So to find the cosine, I must subtract that 25, so that fraction. So I know it's already was a minus, so it's a 1 minus this 25 169ths. Okay. And then you do a little bit of arithmetic, you find the same denominator of 169, right? Put like that and times it also on the top. So you end up subtracting from 169, number 25. And when you do this, you get 144. And this is great. So we get a negative, a square root from 144 over 169. And this is 12/13. So that's my cosine of theta, negative 12 over 13. And that's actually bringing us back to the previous exercise story, because once we have both sine and cosine without caring they're positive or negative, I just need to go ahead and repeat the same story with finding those tangent, its friend cotangent, and the other reciprocals. So that'd be a routine, I guess, for all of these exercises. And that's why I don't ask you to do lots of exercises in this section, because if you know how to do one of them, like 35, then if you do 46, that's it, that's good enough, because otherwise you just keep repeating the same thing again and again. I guess unless you enjoy it, you don't really need that. So this be minus 5 over 13 divided by cosine that we just found, which is 12 over 13, also is negative. And then 13s will cancel, negatives also will cancel, so you get just 5 12s, right? So how come? Well, same idea, so just multiply by 13 over 13, this fraction, so it doesn't change anything, but that way we can cancel these 13s, and whatever's left is 5 12s. And then I just flip this for finding cotangent, so it'll be 12 over 5, and etc. So for the reciprocal of sine, I already know we're going to need to flip that 3/5, so it'll be negative 5/3, and then reciprocal of cosine will be 5/4. So I guess it's a good idea to once take the piece of paper and redo the same thing again, because I believe that if you can reproduce the same exact solution for the exercise, then it's good enough, and that's it. So let me try another one here, and then maybe I'll ask you for something similar. How about if I try one like problem number from the first group? Let me try one with pi for a change. So how about if I try number 19? And then I'll ask you to do number 20 for a little quiz. So I'll do number 19. This is something that asks for cosine of 33 pi over 4. Okay. 33 pi over 4. So I guess I want to make sure that I pull out this pi over 4 part correctly. And notice that if I have 32 pi over 4 added with pi over 4, that will be exactly my 33 pi, right? 32 is 1. Why do I select 32? Because I can nicely divide it by 4, and this will be 8, right? 8 pi. So I just rotate 8 times by pi, and this will be like 4 full rotations. 1, 2, 3, 4 full rotations. That's my 32 pi or 8 pi. And then another little one, like pi over 4, right? So what they want is to know, I think I wrote something a little bit odd. Why did I put pi over pi? Pi over 4. See, I got tired a little bit after a long weekend. So pi over 4 is the angle I need. And now you need to know its cosine. So what's the cosine of pi over 4? Well, it's same as its sine. It's radical 2 over 2. So if you wish to double check this, go to that favorite to that unit circle and locate the angle pi over 4 in it, and you will see that it deals with these radical 2 over 2, right? For both, and for sine and for cosine. So how about analogous exercise if you try to do this on your own? Exercise number 20. The little quiz for today. Take your time. Don't hurry. Don't need to rush with it, please. Just look at the unit circle, pull out the whole part, analogously to what I just did with the previous exercise. Advice is separate 1 pi over 4 and then see what's left. And then give me the answer, which I think is not going to be much different with the answer that I just produced for the exercise number 19. It's a kind of same story. Again, please do not hurry. That's
Professor,
yes.
do you think you can go over 19 again?
Go over 19 again.
Yeah, because I didn't really understand.
So you split 32 with 32 plus 1. 33 with 32 plus 1. That's pretty much all it is. 32 plus 1 is 33. That's why 32 pi over 4 plus 1 pi over 4 is 33 of this. Pi over 4. Oh, sorry. I see why. Pi over 4. See, it wasn't killed. So you divide this 32 by 4 and you get 8. Right?
Uh-huh.
And now I produce the angle. I rotate it by 8 pi. It's 4 full rotations plus 1 more pi over 4. And that's where we ended up. So that's the exact same thing you need to do here, but you're going to rotate less. You're not going to rotate 4 full rotations.
And do we have to look at that diagram to give you our answer?
Well, unless you remember it.
No.
If
Okay.
you don't remember, then you should look at the diagram exactly. And I can open this diagram for everyone who wants. So let me write this quiz number 20. So I'll write this question. It's sine 9 pi over 4. Okay. So that's what you need to find. And how to find it? Well, yeah, you can pull out the whole part and then take a look at this diagram, because that'd be exact same picture pretty much, I believe.
And you don't do anything with the 33 pi over 4?
There is no 33 in this exercise. There is 9.
In 19? I'm talking about 19.
So 33 pi over 4, I split it as 32 plus 1. See, that was the first 32 plus 1. So I split it 33 into 32 and 1. And that's how we produced 8 pi. You divide 32 by 4.
Oh, okay, thank you.
Okay.